Hello everyone and welcome to Tutorials. Today we're gonna solve daily temperatures. So the question prompt is as follows. Given an array of integers temperatures that represents the daily temperatures, return an array answer such that answer at index I is the number of days you have to wait for the ith day to get a warmer temperature. If there's no future day for which this is possible, we need to keep answer at I equal to 0 instead. Now let's take a look at an example to better understand the question. So in the first example, we're given the following temperatures array. The first element is 73, and as we can see, one place after 73 we encounter a 74, which is a higher temperature than 73, so we need to put 1 here. This is because we have to wait 1 day to get a warmer temperature, so the first element in the answer array needs to be 1. And likewise, after 74, we see a 75, so we also need 1 day to have a warmer temperature after 74, so we need a 1 here as well. For 75, however, we encounter a higher value 4 places after it, which is this 76. So we need to have a 4 here. As you may notice, we can calculate the days we have to wait by subtracting the indices of the temperatures. For 79 and 69, we have to wait up until we encounter the 72, which gives us 2 and 1 days to wait respectively. For 72, the first greater value is the 76, one place after it, so we need to have a 1 here. And lastly, for 76 and 73, we actually don't have any higher values after them, so we will put zeros in their places. So the idea is to find the next greater element in the array for each temperature value and calculate the difference between their indices and put that result in the answer array. That's how we're gonna calculate the number of days we have to wait after any day to get a warmer temperature. So the most brute force way to solve this problem would be to visit each element in the array and scan the rest of the elements to find a higher value. For example, for this 73, we're going to scan the rest of the elements and we'll see that 74 is the first element that is greater than 73, so we're going to calculate the difference between their indices and put 1 here. For 74, we're going to scan this portion of the array and we'll see that 75 is the first value that is greater than 74, so we're going to calculate the difference between their indices and put 1 here. And we're going to follow this procedure until the end of the array. However, we need an outer and an inner for loops performing linear time work to achieve this, which gives us a time complexity of O of n squared, where n is the length of the array, and a space complexity of O of 1 since no extra auxiliary space is needed. But as I've mentioned before, this is a brute force way to solve this problem, so we can do better than that. We're actually going to use a technique called monotonic stack. If you haven't heard of it before, it's pretty hard for you to come up with it in an interview setting, but once you get the hang of it, it's a pretty useful technique to apply to a lot of different problems, so it's very useful to learn it, and you will see more of it in future videos. We will initialize an empty stack and the result array to all zeros and start pushing the indices of the days beginning from the first day. However, we will maintain the elements in a decreasing sorted fashion. For each day, we check the temperature against the temperatures of the days on the top of the stack. If the current day is warmer than the day on the top of the stack, we can pop that day from the stack and update its waiting days to the current day. We keep doing this until the stack is empty or the current day is not warmer than the day on the top of the stack. We then push the current day onto the stack. Finally, return the result array with the waiting days for each day. This explanation might be vague for now, so let's see how this algorithm works on the first example. Now here's a temperatures array, here's our result array, and here's our empty stack, and these values show the indices of individual elements both in the temperatures and the results array. So we initialize our results array to all zeros, and the array's length is the same as the temperatures arrays. Now we push the index of the first value in our temperatures array to our stack, and then we visit the first index and see that our visited value, which is 74, is greater than the element that is in the top of our stack, whose index is denoted by a 0 here in our stack, and whose value is actually 73. So we pop this value from our stack and subtract it from the index of the current visited element, which is 1, which is going to give us the number of days we have to wait for a warmer temperature. So we need to update this value to 1. Now we push the index of the current visited element to our stack and advance within the temperatures array to visit the second index, which has the value of 75. Now 75 has a greater value than the value that is pointed by the top of our stack, which is at the first index and which has the value 74. So we need to pop this value from our stack because it violates the non-decreasing order because it violates the monotonic stack. Now we subtract 1 from 2 and calculate the number of days we have to wait to get a warmer temperature, which is 1 again, and we put that value in our results array. Now we need to push 2 to our stack and advance to the third index. Now we see that our third index have the value 71, which is less than the value that is pointed by the top of the stack, so we need to push 3 to our stack because it keeps our stack in monotonically decreasing order, as you can see. Now we advance to the fourth index and see that our current visited value is 69, which is also less than the value that is at the top of our stack, which is 71, so we push 4 to the stack. And after that we encounter a 72, which is at the fifth index, and see that the value that is pointed by the top of our stack, which is at the fourth index and which has the value 69, is less than 72, so we need to pop that value from our stack and calculate the difference between these two indices, which is 1. And now we can conclude that we need to wait 1 day to get a warmer temperature for the value of 69, so we're gonna put a 1 here. And since our stack is not empty, we still need to check if the value that is pointed by the top of our stack is greater than the current value or not. And since our stack is not empty and the top of our stack points to 71, and we'll see that 72 is greater than 71, so we need to pop that value up from our stack and calculate the difference between their indices, which is 2. So we can conclude that we need to wait 2 days to get a warmer temperature from this value of 71, so we need to put a 2 here. Now we're going to compare 72 to the top of our stack as well, but now we'll encounter a 75, which is greater than 72, so we're going to push the index of 72, which is 5, to our stack. Now we have the values of 75 and 72 in our stack, which is monotonically decreasing. Now our current visited index is the 6th index, which has the value of 76, which is greater than the value that is at the top of our stack, which is the 72. So we calculate the difference between their indices and see that it's 1. So we need to put a 1 here in the result array and we pop it from our stack. Now we have the index 2 at the top of our stack, and we see that the value that is at the second index in the temperatures array is less than the current visited value, which is 76. So we need to pop 2 from our stack and calculate the index difference between 2 and 6, which is 4. And at the second index of our result array, we need to put 4, which means that we need to wait 4 days to get a warmer temperature compared to 75. Now, since our current visited element is 6, we need to push 6 to our stack. Now our current visited index is the 7th index, and we have a value of 73, and 73 is less than the value that is at the top of our stack, which is 76. So we don't need to pop anything, and we push 7 to our stack. And now we're out of bounds, so we can now return the result array, which, as you can see, matches with the output in the first example. As you can see, with a monotonically decreasing stack, we have found the correct solution that works in one pass. Now let's talk about the time and space complexities. The time complexity of this solution is O of n, where n is the length of the array, and the space complexity is also O of n. This is because we will visit each element of the array once and potentially push and pop every one of them from the stack, which are constant time operations. Also, the length of the stack is upper bounded by the number of temperatures in the array. Now let's code this solution. The first thing I'm going to be doing is initialize our result array and name it days to wait, which is going to be initialized to all zeros and have the same length as the temperatures array. And in Python, this syntax is going to allow us to have such an array. And then I'm going to initialize an empty stack and start iterating over the temperatures array. And as I mentioned before, while our stack is not empty and the current visited temperature at index I is greater than the temperature that is at the top of our stack, we need to start popping from our stack and to get the index of that value and calculate the difference between the days accordingly. Now we need to store this value in our days to wait array at the jth index. So we're going to do something like this. This means that for the jth day, we need to wait I minus j days to get a warmer temperature, which we know from this condition. And when we're done with this while loop, we need to push the current element to our stack and continue our iteration over the array. And when we break out of the for loop, we need to return the days to wait, because we know that through our iteration over the array, we're going to calculate the number of days we have to wait for each individual day to get a warmer temperature and modify the days to wait array to have the correct value at the jth index. Now we can hit submit. As you can see, our solution is correct. I hope you found this video helpful, and if you did so, please like and subscribe. I really appreciate your support to the channel a lot, and I'll see you in the next one.